the radius of a spherical balloon is increasing at a rate of 0.5 centimeter per minute. Right, so that's what we have given over here. So we have a spherical balloon and whose radius is actually increasing at a rate of 0.5 centimeter per minute. The questions begin here. We have been told that how fast is the volume changing when the radius is 7.5 centimeter. So if you don't understand this question, you need to read it again until you don't understand the problem. So once you understand the problem, let's try to write down what are the variable involved in this question. So you can see here there is a radius of the balloon, so possibly we can represent that by r, right? And then so radius of the spherical balloon is increasing at a rate. So at a rate of what? Centimeter, a rate of 0.5 centimeter per minute, right? So radius is increasing with that rate. So how can you translate that mathematically? Well, we just need to write down derivative of r with respect to t is equal to 0.5, right? Okay, so that is from the first sentence. Let's try to see on the second sentence. It says how fast, okay, something to do with the rate. Then how fast is the how fast is the volume changing? I was reading balloon, how fast is the volume changing? Okay, so we need to find out how fast is the volume changing. So that means if v is the volume, right, if v is the volume, then derivative of v with respect to t, this is what we need to figure out when the radius is 7.5. so we need to figure out this is equal to what when r is equal to 7.5. so all the necessary information that are given over here, I just try to write it down over here. So let's try to recollect all of these information that we have just recently received. So there are two variables r and v, right? So these are the two variables. We have given the derivative of r with respect to t, which is 0.5 centimeter per minute, right? And then we need to figure out what is the derivative of v with respect to t, let's say, right? But not always, but we just need to figure out when the radius is 7.5. so this is the question. All right, so like always on the related rate problem, first we extract these information and then we just work with the relationship that we have over here or whatever information we have given. All right, so how do we begin? If you notice on the related rate problem, we always need to first extract this information, and especially if we are figuring out the rate of change of the one variable, before that we actually need to find the, now once we know what are the variable involved, we need to find the relationship between the variables. So how r is related with v on this problem? What is r? Radius. Okay, what is v? Volume. But volume of what? Sphere, right? So and then r is also the radius of the spherical balloon. So if that is the case, then actually how the volume and radius are related? Is there any geometry related with that? Spherical balloon, right? So sphere. So on that case, what is the volume of the sphere? That does that connect radius, or is there a radius formula that connects v? Right, I believe you know one of the formula, which is v equal to 4/3 pi times r cube. This is the volume of the sphere. So on this case, you can see that the volume and the radius are related with each other, right? So this is the relationship between the variable. So on the related rate problem, whenever we have the relationship between the variable, what do? We try to find the relationship between the rate of change. So we try to find the rate of change, we try to find the relationship of the derivative of r with respect to t with derivative of v with respect to t. How do we get that? What do you need to do? We need to differentiate with respect to t on the both sides. So let's try to differentiate v with respect to t, and let's try to differentiate 4/3 times pi r cube with respect to t, right? All right, so on the left hand side, then we have derivative of v with respect to t is equal to, how do we differentiate 4/3 pi r cube? 4/3 pi is actually a constant, so we can take that out, right? And then multiply by derivative of the r cube. That is what the constant multiple rule says, right? But what is the derivative of r cube? By using the power rule, the derivative will be, bring the power down, which is 3, write down r as it is, subtract the power by 1, so 3 minus 1 will be 2, okay? But that is only if we differentiate with respect to r. But r here, we are differentiating with respect to t. So what do you need to do? Use the generalized power rule, which is, because r is a function of t, right? So radius was changing with respect to time, so that's why r is a function of t. So on that case, okay, we can use like a power rule, which is bring the power down, write down r as it is, subtract the power by 1, but also don't forget to multiply by the derivative of r with respect to t. That is the derivative of r cube. Alright, 3r squared times derivative of r with respect to t. Alright, so what is our goal? Our goal is to find the derivative of v with respect to t when r equal to 7.5. And then so let's plug this information in then over here on the problem and whatever other things we have given. So 4 over 3 pi is a constant, or we could actually simplify 3 and 3 is a common factor, we can cancel out, right? And then we get 1. So we have 4 times pi left over. And then what is r here? We need to find the rate of change of the v with respect to time when r equal to 7.5, right? So if that is the case, plug that information in. So this is square of 7.5, right? And then times derivative of r with respect to t, and we have given that the derivative of r with respect to t is actually 0.5, right? The radius of the spherical balloon is always increasing with this rate, so that's what we have given, 0.5. So if that is the case, plug that information in over here, 0.5. We are done. But I think you don't like that form, right? So let's try to simplify. If you multiply all of the numbers, that means square of the 7.5 times 0.5 times 4, then we will get, can you use your calculator, what you get there? Okay, what do you get? 112.5, right? Okay, and then times pi was missing here, right? So let's write down pi over there. This could be one of the result that you may like it, but if you don't, you can actually also convert everything into the number. So 112.5 times pi will be approximately equal to 353.429, and this is the required answer, and that's how the volume is changing, right? So what kind of answer we get the positive result here, right? So if that is the case, how fast the volume is changing? What does that mean? Derivative of v with respect to t, that means volume is increasing, because we get the positive sign there, right? So is increasing at a rate of 300, let's say 53.4. if you want to just write down one decimal place over there, right? So 353.4. and what would be the unit here? I was like kind of not using the units to just like work on the problem, but what is the unit here? The volume would be centimeter cube, rate of change of the volume would be cubic centimeter per minute, right? Here the time is in minute. All right.